Okay, so we're going to look at the initial value problems, the part that I left off of 6.1 in the last video, because the video got too long. So we have a way to find an antiderivative in general. All right, so if I have the problem, let's say I want to find the antiderivative of this, 3x squared minus 4x plus 8 dx. All right, well, we basically know how to do this at this point, right? These are just power rule problems. So 3 times the antiderivative of x squared is going to be x squared over 2. X to the third over 3, right? Add 1 and divide. Minus 4x, so that's going to be 4 times the antiderivative of x, which is, again, add 1 and divide, plus the antiderivative of 8, which is going to be 8x, and then we say plus c, because we don't know from the beginning if there was a constant involved in the original problem that led to this as the derivative. All right, so then we can simplify this. 3's here are going to cancel, so I'll have x to the third minus, here I can reduce the 2 with the 4, so that's going to be a 2x squared plus 8x plus c. So again, remember we have that plus c there because antiderivatives give us a family of curves. But suppose I knew a little more information about my function. Suppose I know a point that lies on the function, right? Suppose I know that the point 1, 9 lies on this function here. All right, well, then I can take my general solution and make it a specific solution. All right, so if I know that the point 1, 9 lies on the curve, all right, then what that means is that when x is 1 in here, y is 9, right? So if I substitute in 1, then I should get 9. All right, so this is going to be 1 minus 2 plus 8 plus c. And let's see, that's going to be minus 1, which is going to make that 7. And if I minus 7 from both sides, c is 2. All right, so when, I can't spell when, apparently. Let's just get rid of the whole thing. All right, so when 1, 9 lies on our function, we can solve for c. All right, and what we get is, what do we get? X to the third minus 2x squared plus 8x plus c, which we figured out c was 2 for this particular situation. All right, so when you have an initial value, that's what this is called. All right, this is an initial value. You'll be able to solve for c. All right, so now let's take a look at this in a practical problem here. In particular, our maglev train. All right, so we have our maglev train. We did this problem at the very beginning. Sorry. I'm working with my copy of the book here instead of the one online. All right, so we have, all right, so if you're following along at home, this is on page 417. At the top, it's example 11, and it says, in a test run, of a maglev along a straight elevated monorail track. The data obtained from reading its speedometer indicates that the velocity of the maglev at time t can be described by the velocity function, and this is the velocity function that they give us. V of t is 8t, where t is between 0 and 30 and measured in seconds. Okay. Find the position of the maglev. Assume that initially the maglev is located at the origin of the coordinate line, like we've been doing all along. So what that means is assume that the initial position is at 0, right? Okay. So if we make that assumption, right, then to find the position, right, the position is the antiderivative of the velocity with respect to t. All right, so the position as a function of t is going to be the antiderivative of 8t dt, which is going to be 8 times the antiderivative of t, which is going to be t squared over 4 plus c. All right, which is, again, I can reduce the 8 over 2. Oh my God, I'm thinking ahead to the answer here, sorry. Over 2. All right, I can reduce the 8 and the 2, and that's going to give me 4t squared plus c. All right, now, without any other information, we would have to stop there. But if I know the initial position at 0 is 0, then I know that 4 times 0 squared plus c is going to be 0, which means that c is going to be 0, right? Because that whole thing is going to be 0. So I get as my position function for the maglev train 4t squared plus 0, which is just 4t squared. All right, so knowing an initial position will allow you to find a specific position function if you know the velocity. All right, and actually it doesn't have to be the initial position. It can be any position, it can be any value along the curve. All right, so I'm going to add into your homework assignment a few extra problems, and then I'll throw in some what do you call it? The tangent line problems. Oh my God. All right. All right, so let's do one more of these just so I can show you what it's going to look like in the homework. All right, so let's move down to a clean space here. And all right, I got to stop doing these so early in the morning. Okay. All right, so I'm going to add to the homework assignment on page 419. All right, so I think I'll just do one of these just to show you what they look like on the homework assignment. Let's see, based on some of the questions I got from the second class, I'm thinking, let's do 54. All right, so what did I just say? I'm on page 419, number 54. And this is what the problem says. All right, find f of x by solving the initial value problem. So 54 gives us f prime of x equals 1 over the square root of x. And then the initial condition that f of 4 is 2. Okay. So, in order to go through to solve this, right, since we're starting with f prime and we're looking for f is the antiderivative of f prime of x dx. Okay, that's basically the definition of the antiderivative. All right, so for us, for this problem, f of x is going to equal the antiderivative of 1 over the square root of x dx. All right, now again, since I only have the power rule to deal with, I need to turn this into a power function. So the square root of x is x to the 1/2, and when I bring that up, that is x to the minus 1/2 dx. All right, so to take the antiderivative of this, I have to add 1 and divide. All right, so if I add 1 to negative 1/2, I get x to the 1/2. Now, if I divide by 1/2, that's the same thing as multiplying by 2 over 1 plus c. All right, so I get 2. X to the 1/2 is the square root of x plus c. All right, so now to find c, I go back up here to my initial condition. All right, so I have, let me just write this down, f of x equals 2 times the square root of x plus c, and I also have that f of 4 is 2. So I plug in 4, right? So f of 4, 2 times the square root of 4 plus c, and that has to equal 2. All right, well, the square root of 4 is 2, and 2 times 2 is 4. So when I bring the 4 over, c is negative 2. When I bring the 4 over, c is negative 2. All right, so now I can write my whole f of x, right? F of x is 2 rad x minus 2. And this is my original function. Okay. All right, so I'm going to post the new homework assignment, and you should be able to start working on that.